Use calculus to determine the coordinates and nature of any stationary points of the curve y equals x to the 7. So y is x to the 7. First derivative is 7x to the 6. Now for stationary points we want dy dx to be 0. So 7x to the 6 is equal to 0 only happens when x is 0. So there's just the one stationary point. d2y dx squared evaluated, so we haven't actually worked out d2y dx squared yet, so let's do it. We need to differentiate this one again, so that's going to be 42 x to the power 5, and therefore d2y dx squared evaluated at x equals 0 is 0. Now lots of students think that that means that we have a horizontal point of inflection, and indeed on this particular curve we do have a horizontal point of inflection, but the 0 actually tells us nothing, and we'll look at that in a moment. So what would we do? We'd have to then go for a sine table. So x dy dx, and then a sketch at the bottom, and so we know that it was at 0, and this was 0, which means it was flat. Go to the left, go to the right. So at -1, this is, so as dy dx that we look at, 7x to the 6, so -1 to the 6 is just 1, so that one is actually positive. And at 1 it's positive. So that's up, across, up, so we do have a horizontal point of inflection. But let's consider for a moment y equals x to the 6. So what I'm trying to do here is illustrate that this tells us nothing. Y equals x to the 6, we know the shape of that from earlier in the course. We know that that one has a local minimum. So dy dx is equal to 6x to the 5. 6x to the 5 equals 0. Only happens when x is 0. d2y dx squared would be 30x to the 4. So d2y dx squared evaluated when x is 0 is 0. But we know that this one has a local minimum, and that's what I mean about d2y dx squared being equal to 0 telling us nothing. We've seen an example where we get a horizontal point of inflection. We've seen an example where we get a minimum, and it's very easy to produce a situation where we would get a local maximum. So remember, d2y dx squared equal to 0 tells us nothing, and you go ahead and use the sine table.